Hello students, we have curvature defined unit speed curve. Suppose our curve is not a unit speed curve, then we can define its curvature as the curvature of the unit speed parameterization. Curvature of any unit speed reparameterized curve will be the definition of the curvature of the given curve. But unit speed reparameterizations, they are sometimes very difficult to evaluate because the process requires parameterization with respect to arc length, and that process requires a kind of integration which we cannot always do or perform. So we need a formula for the curvature for regular curves directly in terms of gamma, not by means of the reparameterization. Okay. So the result is this: if gamma is a regular curve in R3, then in R3, remember, not in Rn, then kappa is equal to norm of gamma double dot cross product with the gamma dot divided by norm of gamma dot cube. The thing is that cross product is valid only in R3. In R4 or in R5, cross product doesn't make sense. So also in R2 also you can make sense of cross product, because in the xy plane, if you take two vectors and take the cross product of them, then you will end up with a vector which is perpendicular to that xy plane. So still there is a vector, namely cross product of two planar vectors. Okay, now we will start proving this theorem. So gamma is our regular curve, and I will look at d gamma by dt. So d gamma by dt is equal to, that is my gamma dot, equal to d gamma by dt equal to so this is gamma, forget about this gamma tilde and alpha tilde and beta tilde. I don't want that. So here is gamma. So d gamma by dt. So here the variable is s and here the variable is t. So it is d gamma by ds into ds by dt. This is by chain rule. Where this is the unit speed reparameterization, gamma tilde. So in fact the chain rule will give you d gamma by dt equal to d gamma tilde divided by ds into ds by dt, but gamma tilde I am going to represent as gamma only. So this tilde I will remove. So now let us look at kappa. So what is kappa? It is norm of the second derivative of the unit speed reparameterization. So d square gamma divided by ds square, that is by definition of kappa. So that is equal to norm of d by ds of d gamma by ds that is equal to norm of d by ds of d gamma by ds. I am going to write as d gamma by dt divided by ds by dt. That will be d gamma by ds. This is again chain rule. D gamma by ds equal to d gamma by ds equal to d gamma by dt into dt by ds. So into dt by ds is written as divided by ds by dt. That's what. So this is again one more chain rule. So this is equal to norm of I will write this as d by dt of d gamma by dt divided by ds by dt divided by ds by dt. Am I right? Because this is d by dt divided by ds by dt. So this will be d by ds by chain rule again. That is this. And this bracket is kept as it is here. So let me go to the next page. So this is equal to, see what was in the previous page, it is d by dt of this thing. So you use quotient rule. So denominator into derivative of the numerator minus numerator into derivative of the denominator divided by denominator square. So what you will get, denominator is ds by dt. ds by dt into derivative of numerator d by dt of d gamma by dt. So it is d square gamma divided by dt square. So equal to ds by dt into d square gamma by dt square dt square minus numerator into derivative of the denominator. So minus d gamma by minus denominator into derivative of the numerator minus numerator into d gamma by dt into derivative of the denominator. What is derivative of the denominator? D square s by dt square. So that I am going to write first, minus d square s by dt square into numerator d gamma by dt whole divided by denominator square. So what is denominator square? ds by dt whole square, and another ds by dt is here. So ds by dt whole cube divided by ds by dt the whole cube. So there is a norm here. And I will put this equal to here rather than here. So Okay, this is what I get. Now look at a ds by dt whole square. Here ds by dt cube is okay. So I will do one more thing. This is a adjustment which will be useful later. I will multiply throughout by ds by dt in the numerator and in the denominator. So what I will get? Norm of ds by dt whole square into d square gamma by dt square minus ds by dt into d square s by dt square into d gamma by dt whole divided by ds by dt whole to the power of 4. What I have done? Multiply numerator and denominator by ds by dt. Okay. Now S is unit speed reparameterization. So ds by dt whole square, ds by dt whole square, that is equal to norm of gamma dot square. Why? I am not saying S is arc length. I am not saying S is arc length. But S gives a unit speed reparameterization. So you have to justify this. So I will give why this is so. I will explain. So if script S that denotes the unit speed reparameterization by means of arc length, then S of t will be equal to, recall, integral 0 to t norm of gamma dot of tau d tau. So ds by dt will be equal to norm of gamma dot of t and if S is any other unit speed reparameterization, then what is the relation between this S and this script S? S is equal to plus or minus script S plus constant, which we have already proved. So ds by dt is plus or minus ds by dt. T is the original parameter of gamma, which is a regular curve. S is parameterization by means of arc length, which will give a unit speed reparameterization, and this S is any unit speed reparameterization. So this S and this S will be related like this, which we have observed already. But what is ds by dt? It is norm of gamma dot of t. So this is plus or minus norm of gamma dot of t. So ds by dt whole square, it is plus or minus whole square will be 1 norm of gamma dot square. So we have justified this. We have justified this. So this is nothing but gamma dot product with gamma dot product with the gamma dot. Now let us differentiate with respect to t both sides. So differentiating with respect to t, what you will get? 2 ds by dt into d square s by dt square is equal to, you have to differentiate this. So gamma double dot inner product gamma dot plus gamma dot inner product gamma double dot. So it is 2 times gamma double dot inner product with gamma dot, right? This 2 and 2 get cancelled. So ds by dt into d square s by dt square is gamma dot product with gamma double dot product with gamma dot. So let us substitute here. Okay. And what is ds by dt whole square? ds by dt whole square is, it is here. This also we can substitute. ds by dt the whole square is gamma dot inner product with the gamma dot from here and d square gamma by dt square, keep as it is. So this is gamma double dot minus dot means differentiation with respect to t, minus what is this? It is here ds by dt into d square s by dt square is gamma double dot product with the gamma dot. So this is gamma double dot inner product with the gamma dot into d gamma by dt, it is gamma dot. So numerator is this much divided by denominator is what is denominator? ds by dt whole to the power 4 will be norm of gamma dot whole to the power 4. Okay. So I will use another new board. So kappa, the left side was kappa. So how to take a new page? Yes. So kappa equal to norm of, here it is, gamma dot product gamma dot into gamma double dot minus gamma dot product gamma dot times gamma double dot minus gamma double dot product with the gamma dot. So I am going to write this as gamma dot product with gamma double dot. Gamma dot product with the gamma double dot times gamma dot whole divided by the denominator you have norm of gamma dot square, sorry, to the power 4, norm of gamma dot to the power 4. Alright. So this is equal to, now recall what is A cross B cross C. So this is A dot C into B minus A dot B into C. So use this. So what you will get? So this is A dot C into B minus A dot B into C. So this is precisely norm of A cross B cross C. Norm of gamma dot cross B is gamma double dot. Gamma double dot cross, what is C? It is again gamma dot divided by norm of gamma dot to the power 4, which is equal to, now look at gamma double dot cross gamma dot. What is this? This is a vector perpendicular to both gamma double dot and gamma dot. I will use the fact that gamma double dot cross gamma dot is perpendicular to the second vector gamma dot. Therefore, the angle between this vector cross product and gamma dot will be pi by 2, and cross product is given by A cross B norm equal to norm A into norm B into sine theta, where theta is the angle between the two vectors, into vector n. So vector n modulus you have to take, so you will get 1. So sine theta, but theta is pi by 2 here, so sine theta is 1. So norm of this vector is product of the norms, norm of gamma dot into norm of gamma double dot cross gamma dot whole divided by norm of gamma dot whole to the power 4 as in the denominator, so which is equal to gamma dot is non-zero because gamma is regular, so you can cancel one gamma dot in this numerator and denominator, so you will get norm of gamma double dot cross gamma dot whole divided by norm of gamma dot cube, and this is what we wanted to prove. Where is that? Yes, this is the result we wanted to prove. Thank you.